Good morning, this is Mr. Keaton here to talk about 4.6 using congruent triangles. In this activity we're going to look at first establishing that we have congruent triangles, and then after that we will look at being able to use the parts of the triangles for proving other things congruent. So in this first problem they'd like us to use one of the 5 techniques we have for proving congruent triangles. We have side, angle, side, angle, side, angle, side, 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 angle, angle, side, and hypotenuse leg. In this first one we can see we have these angles congruent and then these angles congruent. So we have 2 angles congruent, so we're going to be using either angle side angle or angle angle side. Looks like we can prove this middle side here. The middle side is congruent in both triangles by the reflexive property, therefore we're going to use angle side angle. In problem number 2 we have an angle is congruent and we have a side, so we got angle side. The only way we could do this is with angle side angle, and unfortunately we don't have this angle. All we have is this other side here congruent by the reflexive property, and we don't have an angle side side congruence property, so we can't do that. So we're going to have to say this is not necessarily congruent. We can't prove that one congruent. Coming down to problem number 3, in this one we can use the reflexive property to show this is congruent to itself, and that's all they gave us in that one. So this one is also going to be not necessarily congruent. Let's go ahead and look at the next definition here. Congruent triangles have congruent corresponding parts. So if you have congruent triangles, then you have congruent corresponding parts. So if you can prove that 2 triangles are congruent, and this is the big step, prove the 2 triangles congruent, then the corresponding parts must be congruent. So corresponding parts of congruent triangles are congruent. That's the biggie there. So let's go ahead and see if we can use that in a proof here. So we got a proof. Go ahead and set up a table here. In this proof they said GK bisects angle FGH. So because it bisects it, by the definition of an angle bisected, we know it's going to break these 2 angles, break that angle in half and make these 2 parts, corresponding angles, congruent. So we can say, let's put the given down here, GK bisects angle FGH and angle FKH. That's given. Step number 2, we know because GK is bisecting it, those angles will be congruent. So we can say angle FKG is congruent to angle HKG. Definition of angle bisector. We can also do the other side because it's bisecting angle FGH also. We can say this is going to be congruent to that for the same reason. So we'll just tack down this line here, so we can say FGK is congruent to angle HGK for the same reason. And I'm sure most of you are jumping out of your seat going, hey, that middle side there. So we can use the reflexive property here to say that segment KG is congruent to segment KG. And now we can say triangle FKG is congruent to triangle HKG. And that would be by angle side angle. And now we can finally get to our proof. The last step, I'd say FK. And you can go ahead and say in question number 1 what reason we're going to use here for this theorem. Fk is congruent to Hk, and the reason is corresponding